Hello everyone! How are we all? I am very excited to be here. I thought I might do a little bit of Fusion 360 because I haven't done it in a very, very long time and I miss it. So that's what we're going to do today. We're going to do a little Fusion 360. And it's sort of been inspired by some marbling that I've been doing lately. So I have been getting into bookbinding, which is, the making of books. Hello, hello. Hey, Taylor. Hey, Nelson. Lovely to see you. Hi, Ivor. I hope you're still with us. Hey, Nan. Hi, beautiful people. How are we doing? Yeah. So what I was saying, getting into marbling. So I have been making little books, and I have been making this paper, like not the paper itself, but I have been making the patterns on the paper, and I have been making the patterns on this paper too, which is a different technique. It's not actually marbling. This is called paste papers, and I have been making loads and loads and loads of these things, like so many. And I don't know, I might show off a few because they're quite pretty. Look at that. Pretty. And I really like this one. It's got like this neat speckledy pattern, which doesn't look super cool on camera, but it's gold. It's got like gold on it, so in real life it's very shiny and beautiful. It's got a, oh hey Justin, hey Takey. Hey Electronaut, lovely to see you all. We got lots of keyboard people in here today. That's nice. Keyboard people in the bookbinding stream. I'm happy. Oh, you used to work at a bookbinding company. Oh, well, Nelson, don't judge me too harshly. I am baby bookbinder. Baby bookbinder. This is my first foray. But I'm very, very much enjoying making the marbling, like doing the marbling process, and it's really cool. If you've never seen it before, I might do a video or something on it. Maybe that can be an upcoming stream, because it's really fun. You like get a big, basically a tray of water with some thickener in it, and then you like splatter paint all over the top, and then you use combs to kind of put patterns into that paper, and you can get relatively complex designs. Like, where's that really good one? There's a really nice one. Oh, this one's kind of shows it. There's just so many. The pile is huge. Oh, where'd it go? Anyway, you can get quite complex designs. Like this is called a peacock, or I think some people call it shell or fan. And this is kind of dodgy. This is me experimenting with it. They can get even more complex and beautiful than this. Oh, this is one of my favorites. Check this one out. Didn't that one come out nice? I love this one. So yeah, basically these patterns are made by stroking the paint on top of this water with various shaped combs. And I fashioned a bunch of combs when I started this, and I fashioned them out of cardboard, you know, like good old cardboard and toothpicks, which actually work pretty fine, especially this one. This one I almost don't need to redo. But these teeth, like the toothpicks are just a bit thick, and they're a bit widely spaced. Like you can get relatively intricate ones like this, but normally when you're doing marbling for realsies, you can get a really, really beautiful fine pattern made up when they have quite a few more combs, like teeth in the comb, and it can look really, really beautiful, and I really want that effect. So I've been thinking about how I might go about this and whether I might use the laser cutter at work, but I haven't been doing much 3D printing lately, and you know, I want to get back to my roots a little bit. So I thought I would model these up in Fusion 360, and then use them. Maybe that'll be a good follow-on. I'll model them in 360, and then we can use them in a future week. So I'm pretty keen to do that. And these like this method of making pretty patterns has been around for hundreds of years, and you'll see it in the beginning of lots of old books. It's usually used as an end paper, which is the papers at the front of the books. And so I'm actually going to go with some measurements that have stayed around since forever. So we're going to be recreating hundreds of year old tools using an extremely modern tool, aka 3D printer. So I thought it might be kind of fun. Yeah, they're kind of quite simple tools, but this is a good one if you haven't ever done much Fusion 360 before. This is kind of a good one to get into, I think, because because yeah, you'll kind of learn some of the basics. Speaking of, oh my gosh, I did a workshop for Make Campus recently, and that was on Fusion 360 Basics, and it went so well. And oh my gosh, I just got the most lovely feedback from people. I was like so blown away and like just so happy. So I actually put a post of that on my blog. I guess it's a little bit boastful, but I was just so happy. Like everyone had such a good time and learned so much, and it just made me feel so good. So yeah, thank you to everyone who joined that and made it so lovely. It was wonderful, and I'm very grateful. And it sold out, which is crazy. And people were asking me if they could still get in, and I'm glad I didn't. I know people really wanted to get in, but I'm glad I didn't let them in, because I think any more would have been too many. So yeah, okay, I've been rambling for a bit. Do we want to jump into Fusion and look at some Fusion 360? Might do that, except I want to ramble a little bit longer, because like they're so pretty. There's just so many. I'm not good at it yet, but even though I'm not good at the like traditional styles, they still look good. Like they're just so pretty. Like you can't go wrong. It's been like my zen, you know. You just come home and you just make some pretty patterns on paper, and everything is fine in the world, you know. Like sometimes it's like cross stitch, you know, like it's just enough to keep your brain busy so you can't like be anxious about silly stuff. Yes, water marbling. I think it'll be the new adult coloring in books. I think it could easily go that direction, and quite cheap. Like you only need a few supplies. Well, I suppose not stupid. It depends where you are, but you only need a few supplies to make it happen. So yeah. Anyway, rambling. Oh, thanks, Jess. I think they're pretty too. You always choose the laser. Yeah. I mean, I just wasn't sure how thin I could make the teeth on the laser, and I want them really, really thin, like a third of these toothpicks maybe, or yeah, like I'm thinking 0.8. Yeah, so I wasn't sure how thin I could make them on the laser. Yeah, it is definitely like hydro dipping, Justin. Justin says it's almost like hydro dipping. It is indeed. In fact, I would even call it the proto hydro dipping. It's the hydro dipping we've been doing for hundreds of years. So yeah, it definitely like hydro dipping. And you can still use this technique for hydro dipping. You just need a deeper bath so you can dunk whatever it is in through the paint. So yeah, definitely hydro dipping. Thrasher says, I just spent some time cleaning up my resin printer area. Oh my god, so much sticky, you poor thing. I have a bunch of like silicone mats around that help contain the sticky, because like, yeah, it can get sticky. Martin, lovely to see you. Nelson, do you use any other modeling software? Depending on the goal, yes. So I mostly use Fusion 360 for my more functional items. And I think it's really, really well suited to that, because you can very easily go back and change dimensions and stuff, and it will recalculate your whole model. And I think it's just the most beautiful thing. I am trying to get into OpenSCAD, not OpenSCAD, FreeCAD. I'm trying to get more into that, because I feel like it's probably our future as a maker community. I think FreeCAD is where it's at. I just haven't spent the time on it yet. It's totally my own fault. Yeah, and then I have dabbled slightly in OpenSCAD, but when I go to make more organic models, like, you know, a creature or a character or, you know, trees or something, I use Mesh Mixer or Sculpt GL, yeah, which are other more squishy kinds of modeling software. Yeah. Okay, we should do some Fusion before I bore you all to tears with... Actually, where will we put me? There. Let's put me there. Okay, let's do some Fusion. What do you reckon? So yes, this is what happens when you first open Fusion. This is like a blank document, and this is our solid mode. And Fusion 360 is quite confusing for people generally when they first start, because it has lots of different workspaces for different things. And so this one is the kind of default view, and I like thinking of it like my home desk or my home bench. It's like where you keep bringing a project back to. But there are other modes as well. So we're going to be using sketch mode quite a bit today, which I kind of like to think of as my drawing desk. It has all my drawing type tools there, like my rulers and my protractors and my compasses and stuff to like do good angles and measurements and dimensions and stuff. So we're going to jump into sketch mode first, and we're going to do some sketching. And my comb is going to lay, I'm going to have it looking top down. So I'm going to pop it here. Also, can you guys hear my mouse? Let me know if you can hear my mouse, because if you can, I will do something about it. I just realized I don't have my nice felt keyboard rest at the moment, and it might be a little loud, so let me know. Riskable says no, get into OpenSCAD instead. I like OpenSCAD. I like the customizer and stuff. Like, I like how you can make stuff easily customized and stuff. I mean, you can do that in all of them, but I do really like OpenSCAD. I just haven't spent the time. It's just a time thing. I just keep reaching for the tool I know rather than the one I should be using. I remember marbling Easter eggs once, says Electronaut. That looks neat as well. Yeah, that'd be beautiful. Not Enough Tech says howdy, popping by. Howdy, Not Enough Tech. Riskable enjoys Blender for organic shapes. Oh gosh, you are braver than me. I use Blender very sparingly and only when I need to, because I struggle with Blender. Okay, the main one I want to make today is a very fine comb, and it might seem intuitive to just make, you know, a bar with loads of little stripes on them. But actually, we don't do that with marbling combs, because if you did that, any tiny little fleck of dust that like landed on the top of your water would be picked up by this comb and make big streaks all through the whole sheet. And it would also take up quite a bit of the paint. The paint has a viscosity as well, so it kind of interrupts the paint design more. So what they actually do is they make a array of combs kind of spaced around this sort of distance apart, but thinner teeth, and then they actually offset another comb behind it in between, so that the teeth lie in between the teeth on this side. So that way it's kind of like, it's almost like swirling between the two, but you still get this gorgeous straight line combed pattern. I don't think I have one of just combs, but it makes these like hoop shapes before we do this swirl. So this is like a two-prong process. You would go through and sprinkle it all. Actually, there's a few more prongs in there, but for the sake of this, you go through, sprinkle it all, you comb it in this direction with a fine comb, and then you comb it again with a wiggly motion that makes these big long strands through it. So up here, this sort of pattern here is what the fine tooth comb does. So that's what we're going to do. We're going to do an offset, and I'm thinking to make it printable, what we'll actually do is make it kind of in two layers. So we're going to make one comb, and then I'm going to make another comb, and you print them separately, and then they have like a nice dovetail or something, and they slide together, and that'll make it hopefully stronger as well. But also allows us to offset them without having support material on a wall that is 0.8 or even smaller. Yeah, which would be almost impossible. So we're going to be able to print both halves flat and then assemble them later. So that's my plan, Stan. We'll see how it goes. Riskable says, what kind of mouse are you using that would be loud enough to matter during a stream? Is it powered by Steam or something? No, it's just, my desk is an IKEA one, and it's kind of like that hollow cardboard stuff, I think, and it's just quite loud. Hi, Louiski. Oh, I'm sorry if I butchered that. Hello, though. Not Enough Tech says, I use Blender in the kitchen with the same results. Are you 100% positive this is not a torture tool? Not 100%, but anyway, let's do some marbling. So what I'm going to use for a lot of this is the pattern tool, because then we can make things quite easily reversible, which is handy dandy in my humble opinion. Not so humble opinion, in my opinion. So we're going to make our teeth, and our teeth, I said, was going to be 0.8 wide, so they're just two lines of the printer with a 0.4 nozzle, if that makes sense. You go up and down. So 0.8, and the teeth, this is like a good height for the teeth, so I'm just going to measure whatever this is, which is 4-ish. We'll do 4 centimeters, so 40 millimeters. Boom. Oh, that is not 1. That is not 0.8. That is 0.8. So yeah, dimensions really, really important when you're doing this style of modeling. And yeah, I overuse, no, not even overuse. I use dimensions extensively. I think they're very important and handy. So yeah, I use a lot of dimensions. I think for now, I might actually, what will we do? Yeah, I think I'm gonna create another one of these. Yeah, I've got a plan. I got a plan. Bear with me. We're gonna just do a rectangular pattern, but we're just gonna make one, and we're just gonna work out how far we want them spaced. And I have that handy dandy document of, so the fine tooth comb should be spaced at 5 teeth per inch. Is this it? No, 10 teeth per inch. Ooh, 10 teeth per inch. So that is very fine indeed. I wonder if we'll be able to do that. So, we'll go 1 inch divided by 10. Yeah, that is very fine indeed. But remember, this one is going to be offset above it. So, yeah, this will make sense in a moment. In a moment. Uno momento. All right. So that's all the sketch I want to do for now. And then I think we might work on this dovetail business that I was talking about. And I'm going to do that from this side and create a sketch here. So this is like the head of the comb. It's like this bit. And yeah, I want to make 2 dovetails that slide together so we can have the 2 halves of the comb that lay flat. So I know inches and millimeters, blasphemy. I know, but the thing is, these combs, you know, they've been around for a very long time. So inches was what was used. And yeah, that's what the reference says. It says inches. So we just put it in and then pretend like it didn't happen. Okay, so what are we gonna do? I think this direction, and the head of the comb like that-ish. I'm always doing this. I'm like estimating with my fingers and then measuring what that is on on a ruler. Does anyone else do this? Okay, I think that's about 15 mil. We'll use 15 millimeters. Oh wow, we're really zoomed in. Did I do it? Yeah, okay, we're just super zoomed in. Okay, and how high? Let's go 10. How's that look? Too much. We'll go 7. Yeah, that looks right. We can always change it later. And now we're going to do this dovetail business in here. So I think I won't model both halves of the dovetail. I will model just half and then let it mirror it. So I'm putting in this line here, but we don't need this to be like a real line. We're just going to reference it as the mirror line. So what we can do, and a fancy tool that I learned way too late in Fusion, is that you can turn this line type into a construction line, and then it's not a real line. And what I mean by that is, now we have a line dividing the center, but it still treats this as one shape. If I turn it back into a real line, now I've got 2 separate shapes. Does that make, can we see the difference? Yeah, 2 separate shapes, but if this is a construction line, it's just one shape. Boom. Which is very, very, very handy to have. And then you don't have to like have all these lines and then later go shift and select all these little dots and stuff, because you can just whack in a construction line. Anyway, that will be our mirror line. Not enough tech says, yes, love metrics, not units of freedom divided by the bald eagle squared. I feel you. I feel you. Make and Modify says, I use calipers, but it's basically to fingers with a ruler. I use calipers when I'm measuring like real things, but when I'm inventing something, it's definitely like, what's that? And like measuring it with my fingers. X on the keyboard does that too. Oh, really? Oh, Justin, I love you. That is so good to know. Thank you. Oh, see, these streams, they teach me stuff every time. It's so good. This is like, everyone should live stream Fusion if they're learning Fusion. You'll get told all kinds of great tips. X. Oh, that's so great. I love it. That's wonderful. Thank you, Justin. Okay, so dovetail time. Dovetail time. Dovetail time. So we need... Oh, wait. What am I doing? We need a shape kind of like that. Yeah. And I think I want all these distances to be equal. So more construction lines, maybe? Yeah, let's do a bunch of construction lines. X. Ah, I love it. I love it, Justin. Thank you. And now we can select them all and we can go equal and it'll calculate it out. Nice. Very nice. This too, I think, will actually end up being a construction line, because what we'll do is we'll offset it either way around it, and that will make our like clearance gap. Because when you're 3D printing parts, the printer kind of is not the most accurate thing in the world, and even generally, like I think injection molding parts do this too. You want a little bit of like clearance between things that meant to fit together, so you can actually get them to fit together, because without that it's really hard to like slide things into each other or whatever. So you just want a little gap, a tiny gap to make it all work, so yeah, that's what we're gonna do. So now the easy way to do that is to offset it, and usually I use a 0.3 for parts that need to like slide together, and this is sliding over a pretty long distance. I know on my Prusa Mini I actually learned I can do tighter ones. I think I can do 0.2 pretty easily, but I think because I have to slide these over a relatively long distance, like it ends up being about 25 centimeters total, these combs. So I think I'm going to stick to 0.3, and I'm going to offset it both sides of this line in the middle. So we actually want half of 0.3, which we don't actually have to do the maths for, even though we probably could. But you can go 0.3 divided by 2 and it will work it out for you. And now we only need to do the same, but on the other side. So negative. Offset 0.3 divided by -2. Oh, and it goes the other direction. Yes, we like it. Oh, what else? We got extra tips. Just says, can second the caliper method. Yep, love it. I do know about the dimension key. Thank you, Taylor. I do know about the dimension key. I love the dimension key. D for dimension. Yes. Justin says, drop the Voronoi pattern maker, see if you can work him into the comb. Oh, dang. That could be interesting. I think it's already a pretty small part. It would be cool though, have it like embossed with something. I do still need a space mouse. Maybe one day. I don't know. I'm trying to be more good with my money, but we'll see. L for line. Yes, L for line is great. 0.2 divided by 3, that's cheating. I mean, yeah, you can just put 0.15 in there, but I just want to demonstrate that you can put maths in there because it's very handy, and sometimes you don't have to do the maths. O for offset. Oh, look, the young people here just know all the tricks, all of them. I love it. It's wonderful. Thank you for teaching me. Yes, double clicking a line selects connected lines. It didn't want to work on this one, I think, because I don't know, it worked the first time, but it is definitely connected. Like, it's all connected here. So I don't know why it's not working, but I do know that one with the double click. Like if we do the outlines, it'll work. Yeah. Cool. All right, so we have a dovetail. We just need to mirror it, and we use the mirror function for that, the one I mentioned before. So all the things we want to mirror really is just these two offset lines, and then that can be the mirror. Woo! And so now we have a nice little interlocking dovetail. And I was wondering if maybe I should round the corners some. I think that would be nice. Let's round the corners a little. Maybe not that much. Maybe just a little. Will it make it annoying to print? Yes. It will make it annoying to print. Let's not. Oh, we could do a little chamfer. A little chamfer? Yeah, let's do a little. Just a little chamfer. What am I doing? Where are you? Chamfer. Oh, why is it all compressed? Oh, interesting. Is this? Ooh, whoa. Oh, it should tidy itself back up. Yeah, It's struggling to work out where the middles are. I don't like it. I don't like it. Let's just leave it. It's fine. It's fine. Can be fine, Pokey. Cool. All right. Let's finish that sketch. Let's make our ruler. So let's grab these two lines. Let's extrude them. Extrude-rude. And I only need it to be 25 centimeters. So that is 250 millimeters. Because that is the width of the bath that I'm using, which is actually just a kitty litter tray. It is surprisingly hard to find big tubs that are not too deep. Yeah, I think I'm gonna have to go to IKEA and see if they have any of those under bed like boxes. Anyway, surprisingly hard to find them. So this is our comb, and then the teeth. We got the teeth, so we just need to add some teeth to this. And I don't know how many layers I should make these. 1 mil seems like. Let's go 0.8 as well. So it'll be, if I'm printing at 0.2, it would be 4 layers. That seems right. Yeah, that seems right. Let's do that. And then Fusion does this thing now where it turns, like when you've just finished using a sketch to do something, it'll turn it off automatically for you, which is kind of good because it was confusing to me when I started, but then it also disappears and no one can use it. No one, like, if you don't know where to look for it, it's frustrating as a newbie. Anyway, so I'm gonna extrude from this bottom plane, but I'm gonna attach it to this top one. And the way I can do that is by changing this type of extrude from one side to 2 sides. Oh, look at that. So we're gonna bring this up as well, and we are going to make it the 7 millimeters high, minus 0.8. Yes, 7 minus 0.8. Except we have to do -7, yes, plus 0.8 because we're going in the other direction. Yes, maths. There we go. That's what we want. Beautiful. Now we can turn off that sketch. Get it out of our way. So these are our first 2 combs, and like I said, if you look at it from above, they're going to be quite dense, but we're going to make a pattern to pattern out the rest of this comb so that we don't have to model all these tiny little parts. And weirdly enough, Fusion 360 prefers that you make patterns in 3D. I don't know why this is. I think it's really strange. Like if I was to make this pattern in 2D, it would take a long time to calculate, but it's perfectly happy making it in 3D. So that seems counterintuitive to me, but that is how it works. Yeah, when I was really frustrated once, Angus told me that, and I was like, oh, okay. And yes, I've stuck by it, and it definitely works. It's just really not intuitive. Anyway, so we're gonna make a comb pattern. So we are going to pattern, and it's a rectangular pattern. That is what we're doing. And we're just gonna pattern. So with patterns, you can select what you want it to like duplicate and repeat as part of the pattern. And it defaults to faces, which I actually think is not that useful. I prefer to use something like features because faces can be really different all around a model. This one's a very simple design that would probably be fine if I just select all the faces, but it's very easy to miss a little important face or have it just not work later down the line. So I prefer to do features because it will kind of calculate better. So the feature we want is that first extrude. It's this one back here. That was it before, that was it after. That's the thing we wanna be patterning. So we are going to use that one right there, that one. And the direction we're going in is same as that. X, maybe it's Y. I think it's X. X, yeah. Oh, got it right first go. And we're going along in that direction, and we are doing 10. So with the 2 of them offset, we are doing 10 per inch. So we are doing 5 per inch on the bottom row. So we are doing 1 inch, 5 by 5. Yes. And oh, sorry. Yes, that's another thing. So distance type currently is extent, which means we will fit as many of the amounts you want in the pattern into this space. So like if you had 5 things and 10 centimeters, there would be 0.25. Sorry, they would be 2. If you had 5 things and 10 centimeters, they would be 2 centimeters apart, and you would put 10 centimeters in and it would work it out for you. But we actually want to know that they are evenly spaced, and we want to designate that spacing. So instead we use spacing instead of extent. And now we'll be able to enter a number in, and it will go, okay, I'll add a new one for each like instance of the pattern. I'll add a new one in, and it will be that dimension that you've put in away from the last one. I hope that makes sense. So I will show. Right now we have extent that is that, oh, it's just 5 millimeters. Oh, let's just use 5 millimeters for everything. Oh, let's go back and change it. Let's just make it 5. That makes it really nice. Let's go back and change it here. Sorry. Tangent time. ADHD. Woo. So we're going to use 5 millimeters. Or is it 2.5? Yeah, it's 2.5. Yes. Okay, because it's 5 millimeters later on. Yes, and this one will be 5. This one will be 5. So if we have, goodness. Oh, why does it keep taking us back to the feature when I double click that? Weird. Let's just delete the pattern. We'll start again. So features, we want it to duplicate this one. And if we keep it with extent and we put in our 5 millimeters, and our direction being that X origin, it would try and fit all the amount into this 5 millimeters. So if I change the quantity, it would just keep trying to fit them in, which is not what we want. We want spacing, and we want that spacing to be 5 millimeters. And now when I add more, we'll just add them on the end. I hope the demonstration made more sense than my ramble earlier. What do we got? The sharp corners won't print properly on a printer without pressure advanced and be able to fit. Why is that? The sharp corners should be fine. I wasn't missing a constraint anywhere. It was that as I was adding the chamfers, the middle point was changing. So when you have the box, and you add a chamfer, you're actually taking like 2 mil or whatever off the side. And so the middle point of that line is shifting. So originally when I had that mirror line at the middle point, it was the middle of this long line, but this long line just got shorter in this direction. So the middle point changed. That's the reason. It wasn't because there was a missing dimension. It was actually just because that's how it works. I could probably have started the design on the origin point, like started the dovetail on the origin point, and then that probably would have negated that a little bit. But then I would have also had to start the comb on a different point. So I could have just started with the dovetail. But this is feeling it out. We're feeling it out today. I didn't do too much planning for this one. I kind of wanted to show kind of a looser sort of method to getting where you're going. Would a paper developing tray be the right size? Ooh, that sounds interesting. I will Google. That sounds likely. That sounds very cool. I'm pretty certain Fusion's code is very pastel-like. Aw. I'm sure lots of people work very hard on it. That's neat. Didn't know you could pattern a feature from the timeline. Yeah, in fact, I recommend patterning a feature over patterning faces. Because yeah, faces are a little bit hit or miss. Like, things can go a bit squiffy. If you have sort of a complicated design, it might not know where to put that face and how that face relates to everything else. But features, generally, it does a better job of. I just realized I hadn't taken my meds, and that's why I'm having such a hard time thinking. So just fixing that now. What else we got? Hello, everybody. Hello, Mr. Maker. You can use division in the floor function to make the number of items fully parametric. Ooh. So what do you mean? Like, could I make it so that it fills to the end of the extrusion? A moose? Because that would be awesome. I would like to understand how to do that. Is there a video? Because that would be very cool. Mr. Maker, I always have huge respect for people who do this kind of work online. I already hate it when someone is watching me behind me. Yeah, well, you're in front of me, so it's totally different. Oh, I could pattern both features. I totally could. You're totally correct. Let's pattern both features. That would save us a little bit of time. Let's do. Sometimes it doesn't like it if you. Yeah, okay. Sometimes it doesn't like it if you do the rest of the settings before you, like after you select the objects. Don't know why, but sometimes it doesn't like it. So anyway, we'll do a whole bunch until we fill it up. There should be like 20. Oh no, it's doing the, why? Actually, it might not. It might not. Oh, is it going to? If it does, we can fix it. We need, I think it's going to be 49. Maybe it's just 50. Whoops. Yes, okay. Too many pattern instances is freaking out. But it would also freak out if we did it 2D. I think, is it gonna make it longer? No, it's not. Oh, phew, it worked, yes. I think it was just confusing us at the preview. I did think it was gonna work and it did. Yay, so that is our comb. Check it out, check it out. I was thinking I might try and print it on the belt printer, though I actually realize now it's small enough to print on other printers. But I was thinking it might be fun to try it on the belt printer, printing like this direction. And see how it goes. It'll be interesting seeing it coming off the other end. But yeah, I will now, this bit has to print on this face here, so we might as well flip it over. What's the best way to do this? There might be, yeah, we might set the pivot to, we want to select the body. Can we set the pivot to something else? I think we can. I think we can. We're going to set the pivot to the origin. And then, nah. That's okay. We'll do it in 2 stages. We will go that away, 180, and we will chuff it on over there. And then we will use this point to point. I like the point to point. And you click this point and that point, and now it'll snap it. And I might also just like move it over just a tad, so we don't get confused when we look at it later. So there, that is one of our combs. Woo! Check it out. Oh, we're making great time. Too good time. Well, in that case, I might try doing this larger one. And I feel like this is probably a similar design, just with, actually, we might even be able to just duplicate this whole situation to make this kind of comb. And then I was also thinking, so in order to make this pattern, which is my favorite, because it's just real pretty. This one's my favorite, but it's really hard to do. You have to like wiggle it at just the right kind of period, like just the right amount and just the right repeat. Like you have to wiggle it very specifically, and it's hard to do. And I was thinking it might be cool if I could put a little rail on the side of my water tank that I can actually slide the comb along. So I might try doing that with this rake, this next rake we make, this next comb. So we'll make this one, and then we might try and make the thingy that makes this happen. Yeah, if this makes sense. Brain. Right, Billy, lovely to hear your accent again, but things need to be done and I have to scoot. Be careful with this torture tool. Don't stab anyone around you. Thank you, not enough tech. Have a good one. I'm sure there's a use case, but I've never had to pattern faces, always features or bodies. I agree. I don't know why faces is the default. I think it's kind of a janky way to do anything, and almost always you can do it with features. Heck yes, stimulant meds, Rob. Yeah, pretty much actually. I am a lot better on them. We'll see. In 20 minutes, I'll become way more articulate. You'll watch. It'll happen. You can divide an edge length by spacing. Take the floor and divide by 1 millimeter so it's unitless. Ah, yeah. That makes sense. That makes sense. I get it. Add it with control key, as in add the unit with control key. That sounds right. Sam, I'm late. Aw, not too late. We made our comb, but we're gonna make more, so it's all good. Listen to that warning about the computing option. It helped me a lot when I kept crashing Fusion with a complicated pattern. It was only 1 over the computing? I think that means it's okay. I suppose I could pattern it once and then pattern it again. I could do it like 25 times and then do it again. Anyway, Ethan's dad looks good. That should print easily. Yeah, I think so too. I think this will be a good one. And, you know, I was looking on Thingiverse and Prusa printers and stuff before I started doing this, and there's just nothing in the bookbinding world. There's a couple like punch jigs, but there's no like marbling tools or anything out there. So I think it'll be nice to have some of that. Yeah, so anyone who is new to Fusion, I thought before we move on, it might be handy for me to just demonstrate a little bit of the cool things that Fusion can do. So if I wanted to go back and change the distance between these comb teeth, I could very easily do that. And I could roll the timeline back down here at the, oh, my head is in the way. Put me over there. Yes. So down here at the bottom, we have a timeline. And the timeline is the magic of Fusion. This is the coolest part of Fusion. And you have a little playhead here, kind of like if you were doing video editing or something, and you can click that and drag it back in time. And it goes back to where things were before. And you can keep going back and keep going back. And you can see the whole process of how you made that thing, which is so handy because you can also go back and change one of those things. So we can come back to this pattern to decide, I don't want it 5mm. That is way too tight. I actually want it 10. And it will go back and recalculate that. And of course, because we have too many and I haven't done the cool floor thing, we have some poking out the ends. But these are all now 10mm spaced. And if we look at it from above, they are now 10 apart, 10. But of course, this is not quite right because we set that manually. But anyway, I could have set up a parameter and made it all neat and tidy, and then it would all totally recalculate everything. But yeah, this is the magic of Fusion. You can go back and edit things. So if you imagine you had a really complex design with like loads of little screw holes, and then you went and printed the thing out, and all the screw holes were just a bit too big and your screws were like falling through them. If you were doing that in Tinkercad or Blender or something else, you would have to go through and redo all those freaking holes. And in Fusion, you can just boom, change one parameter and it all automatically calculates. And if I was doing something like that, and probably the better way to do even something like this would have been to originally set up some parameters. And in here, in the parameters, you can create your own user parameters. And these are just like fields, like, yeah, like a box you can put a number in and you can change that number later and you can just refer to the box rather than the number, and then you can just recalculate stuff later. So a better way for me to have done this would have probably been to have a parameter saying spacing or like tooth spacing, and then I would have used that tooth spacing when I made the first pattern in the sketch, or the first pattern in the sketch. I would have said half of that spacing, and then later on when I went to make the feet, the three-dimensional pattern, I would have said the full width that spacing, and then when I recalculated it later, it would have all just boom, magic, perfect little comb. It wouldn't have had all the sticky outy. It wouldn't have had all the like two thin ones and then a gap, and then two thin ones, then a gap, etc. But I kind of feel like I won't be reviewing this much, and this is a pretty simple thing. It's pretty easy to just click back on one of these features and change it. So there is a balance between like making everything ever a parameter, especially because you need to have made the parameters before you make the thing, which is kind of tricky to do sometimes, to think of all those little parameters you might need and then before you make it. But if you've made a design previously and you want to make it really customizable, it's really good to remake it with all the parameters that you know you'll be needing, because that, yeah, makes it very, very versatile. So yeah, I just export and flip it in slices, says make and modify. Yeah, that's another way to do it. Definitely. Chipped builds, hey all, finally caught you live. Ah, lovely to see you. So good to see you. I'll teach you FreeCAD one day. Thank you. I'm not terrible at FreeCAD. I mean, I'm not good at it either, but Brody Fairhall has some great videos and I followed those and got it, and it was good. When dimensioning something in a sketch, you can type a variable name of your choice. Yes, sorry, in case I didn't. Oh, ooh, a variable name of your choice equals blah. And it will make a parameter on the fly. Are you serious, Moose? That is so cool. I didn't know that. Oh, let's do it. Let's do it then. Let's do it. Let's do it. So we had this spacing on this pattern, this 2D pattern here, and we had the distance 2.5 millimeters, but we want it to be half of the spacing. So let's go tooth spacing equals 5 millimeters. Yes. And we want to divide this by 2. Awesome! Okay, that's great. Oh, look. Thank you, Moose. That's awesome. So now if we finish that, and if we change this one here to... Okay, we got it. We got it. If we change this distance to tooth spacing. Oh, okay. I really should, maybe I should split the pattern out. Anyway, tooth spacing. What did I do wrong? I did something wrong. Oh, it's because I did 100. Okay, I need some brackets. I think. No, tooth spacing. Hang on. Let's look at these. Let's modify our parameters. Let's just have a quick squiz. Yes. Okay. So we need some brackets. So it should just be 5 millimeters in our parameters. And then in here, for this specific instance, we go tooth spacing divided by 2. And now divided by 2. Why divide by 2? Oh, did I delete the parameter? Equals 5 millimeters. Okay, so we definitely declared that. And now maybe I'll just put brackets around this. Yeah, divided by 2. Yeah, okay, that'll fix it. And then we'll just check this parameter. No, it's still doing divided by 2. I can't declare it and use it in an equation at the same time, by the look of it. I can't declare it as well, it gets confused. Oh, okay, that's all I needed to do there. Oh, it must have still kept the old one, maybe? Anyway. So now we have the tooth spacing being 5 millimeters in here. Actually, the tooth spacing is 2.5, isn't it? Is that too tight? That seems too tight. How many? Oh no, that would be, yeah, that seems right actually. Anyway. So declaring it and trying to use it in calculation at the same time, not so successful, but declaring it is really cool in the equation. Oh, now it's not offset anymore. What did I do? I must have used tooth spacing. Now we gotta do divided by 2. Is it gonna, no. Okay. I am not demoing this very well. Let's just undo all that. If I had gone make a parameter and the parameter be tooth spacing, I could then use tooth spacing in that field and it would all be fine. But I think because I was trying to declare it and also use it in an equation that it was freaking out. Let's just make this. Come on. We'll just go 2.5. We know this was working. And I don't think I'll be changing the dimensions because this is how the comb should be, and I know that. And we are going to put it here as just 5. It's not going to be tooth spacing, it's just going to be 5. And we're going to hit OK. Okay. And now when we look at it on top of each other, they're fine. Yes, everything is fine now. Whoop, whoop, whoop. No, I didn't want to make a sketch. If we look at it on top, they're offset. Everything is fine. Everything is fine. That will be a really good tip for in future though, when I'm not trying to also use it in an equation. Oh, it won't be in user parameter. Okay, interesting. Hi, Sienna. If you want to see a variable made on the fly in the worksheet, you have to click the drop down for the sketch it belongs to. Anyway, I removed it, but but we'll do that in future. Maybe we can try that on the next one. Let's try it on the next one. So, I created a new document. Let's create some parameters. Let's create this one as tooth spacing. We'll make a new one called tooth spacing. Tooth spacing. And this one should be, we will check the documento. They call this one a rake. The other ones are combs. I don't know why. Kind of feel like that's a... Just like if they get wider space, they become a rake. Because also like... Where'd it go? This one with the wider teeth is also called a rake. So it must just be a comb when it's fine and a rake when it's wide. Anyway, so these ones are a 1.5 inch triangle pattern. So we'll go 1.5 inches. Beautiful, beautiful. Okay, so we have that, and we can reference that in here now. So let's do it again. We're kind of making the same thing. Let's start. Let's learn from all our mistakes. Let's start with the dovetail, and we can we can put that on this center rectangle, and then we can use the origin as our mirror line. Yes. So we want them to be spaced. Oh, I'll have to do a little bit of maths, won't I? Will I? Won't I? No, we're good, I think. Are we? I'm just thinking, I think the triangles have to be equilateral. Yeah, we won't be. The triangles are equilateral, so there'll be 1.5 this way, but this won't be 1.5, and that will be how high our dovetail is. So we just need a little bit of Pythagoras to do that, don't we? Yes. Or we can just draw an equilateral triangle and get it to work that out for us. So let's do that. We will use an inscribed polygon. Yes. And we will give it 3 sides. Yes. And it can just be whatever for now. And this dimension will be our tooth spacing. Tooth spacing. Yes. Yes, and this will give us the height of the comb. Yes, it will. It will. I don't know whether that'll make sense to anyone else, but it makes sense in my brain, and I think we're fine now. But that... Oh, I shouldn't have put that on the center point because we need that to be... Yeah, we'll just do this one more time without it being on the origin. We'll draw in that mirror line now because we'll reference it for this triangle. And we will use X to make that a construction line, and we're going to put another polygon in, and it's going to be inscribed polygon, and we're going to do this again, and we're just going to click it wherever. Oh wait, can we change the sides still? Don't think we can change the sides still once we've made it, but we can do inscribed polygon somewhere here. We can click it to the top. That does... Oh my gosh, I just did it again. See, my meds have not kicked in yet. We can tell. Tab 3. We want a 3-sided polygon, and now I will click there, and this line will be our tooth spacing. Tooth spacing. Okay. And we want this to, like, triangle to sit halfway between the two. So if I put another click here and another click here, yep, and this is also a construction line, we can select them both and hit equal, and boom, the triangle will be equal, except it's not equal. Did I hit the wrong line? Why should they not be equal? Equal? Why? Maybe that is, and it's just me. Let's just quickly... It probably just is a visual weight thing. So that was 16-ish. And that's 16. Okay, it is equal. It is equal. Oh, so that was the center of the polygon last time. It's just me. It's just me. I just think that looks smaller than that, but it's not. It's because of all the volume there. It's just a brain thing, I think. Oh, what are you catting, Techniac? Lovely. What's a marbling tool? Oh yes, so you must have missed the beginning. So these combs and rakes are used in making pretty patterns for the beginnings of books. These sorts of things. This one doesn't need any combing. This one's kind of freeform. Where's another combing one? Combing. Are there more? Yes, there are definitely more. More combing. Yes. So these little combs that I'm making are, I mean, you could use them for hair combs, but maybe don't. They're used for marbling, for making pretty paper, which is, yeah, hydro dipping paper essentially. Yeah. The tools break up the paint on the water. Yes. It's possible to get some obviously copyright-free music going. Oh, I don't know. Maybe play your own. I hate deciding music for other people. Like, I was very reluctant to put it in my videos for a very long time because I hate, you know, when you're watching a video, thinking about adult videos mostly, but when you're watching a video and some music comes on and you don't like it, and then the video becomes unbearable. So put your own music on in the background, please. When dimensioning something in a sketch, if you want to reference it in an already unnamed dimension, you can just click it and it will pull it into the text field. When dimensioning something in a sketch, if you want to reference an already created unnamed dimension, you can just click it and it will pull into the field. Yes, yeah, definitely. And it will say like D4 or whatever, because it's the 4th dimension you made. Yeah. And then you can add maths. Yes. So if I wanted to take this dimension and, I don't know, work out what half of it was, I could go over here and create a line like that. And then I go, this line, dimension, should be this line here divided by 2. And it will give you that. So yeah, you can do that. It's very handy, not in this instance, but in general, very handy. 12 p.m. here. Joke good night. I think you mean 12 a.m. then, but good night, Sam. Gotta go, 11 p.m. here. Lovely to see you make and modify. I'm sorry for everyone in Europe. At least it's a little better now with the time zone difference, whereas like slightly better than we were. So yeah, good. Center is not coincident with the origin. Yeah, oh yeah, it isn't. It still isn't. Yeah, okay, so I was right the first time. It still isn't coincident, but we want it to be equal either side because later, yeah, I want it to be equal because we're doing the dovetail thing here. That's all. And this actually doesn't need to be a real triangle. This can be dimensions, but it's just so we can find the equal point of this. So we don't have to manually calculate the height using Pythagoras and then all that jazz. So we have the equal point of this triangle. I appreciate your choice not to have music. Thank you, Sienna. Kathy, music is annoying. Yeah, totally agree. I put your own music on in the background. You can play 2 things at once. Thanks for not putting music into videos. Everyone has strong opinions about the music. I feel like I have hit upon a point. Yeah, I feel the same. So definitely put your own music in. Techniac, I removed the screen, so I need a way to see what the printer is doing. Oh, interesting. Another electronics channel recently purged music from their vids. Response was big applause. Yeah. I've started putting them in the background of my YouTube videos, but it's just like repetitive, weird electro music or whatever. Yeah, it seems like YouTube kind of needs it for the energy or something, but I think for a live stream, it's kind of like a podcast-ish thing. I wouldn't want to put music. I don't know things. I'm just going with what I enjoy, and I don't enjoy music in the background of many stuff. I find it harder to actually hear what's being said. I don't know whether I'm hard of hearing or what, but I really do struggle. So anyway, dovetail time. I think this is getting kind of complex. Not super complex, but it's more complex than it could get confusing. So I'm actually going to finish this sketch, and we're going to put another sketch on top because we have infinite sketches. We are in design fantasy land and everything is fine here. So yes, we are going to do a new rectangle, and this is where we will do our dovetail. Yes. So just thinking. Yes, it'll be sort of this shape, and what we'll do is, I'll just drag it out to make it a bit more obvious. We are going to make this line and this point, the top of our triangle, coincident, which means joined together, they snap to each other, which is what we want. Yes. And this doesn't have to be particularly wide. We just need enough room for our dovetail. So what did we use in the last one? I think we used 15. Yeah, we used 15. So we're going to put another dovetail in here. We're still making the dovetail side. The triangle might make it confusing, but that was just so I could get the spacing right for later. Yes, it will all make sense eventually. Just trust my madness for the now. And I might just turn this triangle sketch off so that we're not confused by it. So we're gonna make another dovetail in here, and to do that we need a mirror line. So we're gonna use this origin point because we have it here. I might actually snap it to, oh, I won't snap it to the midpoint. I'll make it horizontal vertical, which already is. That weird little jagged sawtooth thing is a horizontal vertical, and we're going to make it a construction line so we can just mirror it nice and neat. And we're going to do the dovetail thing again. I don't think I'll make it as wide as I did last time. We don't need the dovetail to be a third of the whole way, so we're going to use our gut a little bit on this one, and we're going to go something like this. And I realized last time I probably could have made the dovetail like a proper angle. So let's do that this time. Let's use 70. 70 sounds right. I mean, it's kind of fine. It's unnecessary, but we have the power, so we may as well. And the dovetail should be roughly equal, I think, either side of this line. So we will still, what will we do? We'll draw a line from here to here that can be a construction line, and then we'll find the midpoint of that line and draw it out to here. And now we will turn these into construction lines with X on our keyboard. Oh, I love this so much. Thank you for teaching me that. And then we will select this point and make it coincident. Boom. And now that is directly center our origin point. These lines, and no matter where I drag them, they will always be centered either side of our origin. So I like that. I'm going to bring this little angle in just a bit because it kind of gets a bit confusing all the way out there. So yeah, I think like there's a lot, like you could definitely work out a lot of stuff I'm doing with like just plain maths. And I think when I first started Fusion, I did that because I was more used to, you know, doing physics in high school and stuff, like, and chemistry and crap. You just work all the maths out and then put, you know, like this line should be exactly that long or whatever. But you can actually just do a lot with geometry. You can just add a couple of construction lines in, and that's why I say the construction line was a bit of a magic moment for me, because yeah, you don't actually have to do that much maths if you just relate things properly to each other. You don't have to do that much. So yeah, oh, your timing is great. I'm just tired today, no worries. Oh, thanks, Make and Modify. I didn't mind your music choice for vids. I think background music simply happened on YouTube because people couldn't get rid of the microphone noise. Yeah, maybe. My background music on my videos is literally me opening up GarageBand and finding one of the default, like, they have like mixer pads kind of things where it will like play some music, like play a bunch of different tracks on loops, and then I literally just open up one of those default ones, and then I just change some of the sounds at random points in the music, and it just turns out fine background noise. Like, it's not good, but it's fine. Because it's like the copyright thing is so weird with music. Like, an artist can release stuff for free and then say anyone can use it wherever, and then later redact that and say, actually, you all have to pay me now, and then YouTube will take down all those videos, which is crazy. So I'm just like, okay, I'm just gonna, even though I suck at anything musical, I'm gonna try and make my own music, and that's how I do it. It's just GarageBand, except I'm running out of like good background sounding music mixer boards, so I'm gonna have to start making my own from the things there. And everything I gravitate towards is like very Lorne, L-O-R-N, which is like, he does this really sort of experimental electronic synthy music, which is just so divine, but like not good background sound. So everything I gravitate towards is like all these awesome Lorne sounds with these cool claps and swishes and stuff, but it would never work as background music, so I'm gonna have to like sit there and be like, what are good background music sounds, and like assemble my own for a bit. It's gonna take longer, but anyway, that's a future me problem. Oh, Techniac, thanks. Gonna be in a 3D printer case with frosted acrylic rounds. Oh, that sounds fancy. Electronaut, it's hard for me to follow what's being spoken with music on. Same, totally agree. Especially when I'm not looking at the screen for a moment. Totally agree. I even watch most stuff with subtitles. I think maybe I am hard of hearing. I even watch almost everything with subtitles. So maybe I'll do 2 versions of videos. Like do a no music and a music one. Tell me if you want that, because I'm very happy to do that. It's very easy for me to just mute a channel and re-export it. I've never opened GarageBand, so a few steps ahead of me. It's actually really easy, Ethan's dad. I am, oh, Marcus, you've got Marcus there. Very easy. Like, it's really hard to make something that sounds terrible using that software. It's very, very handy. Yeah, the YouTube music library submissions can't be retracted. I get that, but also they're in every video ever, and like that craft one, you know, the craft one, and it's like, I could probably sing it, but I'm not gonna try. But like, there are some that are just so used everywhere, and ugh. Can you try a Rhino tutorial? I don't know any Rhino. I can't afford Rhino, so probably not, sorry. Yeah, I don't have the Rhino dollary doos. Yeah, no. I try and do stuff that's accessible to everyone, so cost is very much a factor in that. Check this out, you guys. Look at this. If I double click here, it selects the whole Z shape for our dovetail, and if I hit construction line, fine. And if I double click it again, I can only do half. Isn't that weird? It like breaks it. So strange. Don't know why that is. Anyway, we're going to do the same thing we did last time. We're going to offset it by 0.15, which is that, because I want a total of 0.3 clearance, and we're going to do a negative 0.15. Yeah. So that's that. I think this is looking a little thin down here. I think that'll end up a bit thin. So we might just like, maybe we change this angle to 60. Oh, no, less sharp. We want 80. Oh, that's too, no, let's keep it at 70. And we'll bring this line over here a little and bring it a little closer. Yeah, I think that looks a little healthier. Alrighty, mirror time. Mirror time. I use the mirror all the time. I use it so often because why remake something when you have a computer that can calculate it for you? So yes, mirror, look at that. So we have two parts, and the center of those, where they join, is the center of our dovetail, which is what we want. So even though this line here between there and there is longer than this line there, where they join in the center is the center of the whole mass. So that's what we want. That is where we're at. And we'll just check that our triangle is still sitting on the top there, and it is. It's good to kind of check, because sometimes you might miss a dimension or a constraint, and sometimes things can go squiffy. So it's good to just do a little sense check every now and again. It's easier to do it as you go rather than at the end, and you're like, why isn't it working? So yeah, a little sense check every now and again is good. So that is that. That's the dovetail done. Kind of a complicated way to make a dovetail, but it will make the rest of this easier with a bit of luck. So let's start doing our teeth. Forgot the word for teeth. Let's start doing our teeth. And we'll create a sketch on the top. We can tell we're in the top, by the way, because it says top up here in the top. And if you rotate around things, this little box will rotate with you. And if you ever get lost, like, say you have a very complex model and you're like, what am I even looking at? It happens. Trust me, it happens. You can always hit this little home. So when you hover over the box, a little home appears, and it will take you to this nice isometric view of whatever, and it will fit the whole object on your screen. So you'll get a view of the whole thing, which is very handy. And also on the box, you can hit like top and it will snap you to the top view, or you can hit front and it will snap you to the front. And super duper handy if you ever get lost. This box is your guide. Lovely box. So top, we'll go to the top. When you move your mouse, so you can hear my mouse. Okay, I'm gonna go get a piece of felt. El Cheapo keyboard rest, big piece of felt, which is very dusty. I hope I don't start sneezing. Okay, we'll put this on here, and it's now it will be slightly quieter. I thought you couldn't hear it. Y'all was saying it was fine earlier. It's not fine. Not fine. Oh, where's my hair? It's annoying me. Okay. So if you already covered this, just join. What size gap did you have between both sides of the dovetail? 0.3. Yeah, sorry, we did make one a little earlier. We made another comb here. So we're kind of doing this, but different scale. So yeah, 0.3. 0.3 is the clearance I use between most of my like slide to fit parts. You can, like on my Prusa Mini, 0.2 is better. But I'm using 0.3 because it's sort of the standard between lots of different printers. It seems to work for most people. And I can always just add like a little bit of glue in between these parts because I will never really need to take them apart again. So 0.3 total, yes, 0.3 total, 1.0. 0.15 either side of my center line. Yeah. No, you scared her off. No. I don't want you hearing this stupid mouse noise. Never seen an adult movie with those subs though. Would be interesting. Ha! Ha! You clearly don't know about my internet history pre 3D printing. Anyway. Maybe because the vertical line is also a construction, so Fusion doesn't know what path to follow anymore. Yeah, that'd be it. That'd be it. It's like, which one are you stuck to? Definitely, that would be it. Sorry everyone, I paused the stream. Bad me. You paused it? No, that's fine. You just got to hear me rummaging around, accidentally hitting the 2D printer, because I was trying to scan all the marbling for you before we started, which I should have tried, you know, yesterday, but ADHD. I was like, oh, it'd be nice to have them in a PowerPoint so I could just like flick through them rather than holding it off in front of my face. And I tried to scan them on my scanner with the thing that goes zoop, zoop, and like pulls them through, and it didn't like them. They're too thick. So I tried, but that is why I buffed the scanner right before when I was rummaging. Anyway, we're back. We're back. Oh, gotta go, Nerdy McNerdy. Have a great day, Billy. My first time on the stream, and it's been freaking awesome. Oh, thank you, Nerdy. Thank you. Have a lovely evening, maybe. But yeah, lovely to see you. Thanks for joining. It was lovely. Yeah. Anyway, comb time. Comb time. What are we doing? So this is the front. The comb needs to go that away. That away. Yes, we're gonna look at it that way so we don't get confused. All right. So this is the top of the comb. We don't need to draw that bit. What we need is to draw the teeth. And this one won't have to be as long as the other one either, because we have to leave room for the swooshy thing. So the other one was 25 centimeters long, 250 millimeters. But because we have to, like, this one goes through the water like this to make that pattern, which looks like this. You go do, and you have to try and, I don't know, I'm gonna have to experiment with the wiggle a little bit, because I think the wiggle has the same period as the distance between these teeth, I think, because I think that means that it meets back up, but it could be double. I'm just not sure, and I don't understand the pattern well enough yet. I think it's double. Anyway, I don't understand the pattern well enough yet, so we'll leave the parameters very open for that one. And I think, thankfully, it's just a circular wave, like 2 semicircles together. Here's hoping, because otherwise it's going to get very complicated with parabolas and stuff. But people, like, traditionally, marble is just like, and they just magic that shit, you know? They just practice it a bunch and they're just instantly perfect. But we have digital fabrication, so we're going to digifab it, so I don't have to practice, because I'm not good at practicing. I'm not good at practicing. Oh, Ed! Hello, Ed. Hello, Ed. All right, comb time. Oh my god, so much rambling. Oh, this is a good opportunity to show you a cool thing. So I want to reference this point here, but I can click it. But sometimes you can't click it because the point is not intersecting this plane that the current sketch is on. So what you can do is you can create a projection. So if you ever want like a bit of another sketch on this sketch, or a bit of your existing model on this sketch, you can use the project or include function, or project or intersect function rather, and it's so handy. So say you have like an object and you have a sketch halfway through that object and you want to know where that little V shape cut out of this object is on your sketch, you can use the intersect function and click on that body and it will give you a full outline of that whole body, which is so handy, and then you can reference that little point if you want it. But we're going to use project in this one, which allows you to click on some geometry and bring it onto this sketch as well, and it's linked. So if you change it on that original sketch, it will also change here. So it's all really neat. So we are going to click on that dot right there. That's the dot we want, and we go okay, and it will be purple. It's really hard to see, but it is indeed purple, and anything that you project will be purple. So you will know that it's not a real line, you can't drag it anywhere, but you can reference it, which is very handy, So let's do that. Oh, we lost our lines, but that's fine. I don't need them. We don't need those lines. So we're going to do a tooth, and I think we're going to keep it, these rakes usually are a bit thicker. So this matchstick head is actually like the right thickness. And I'm going to grab some calipers. I think they're about 3 mil. My gut says about 3, but we're going to measure. if you are a 3D printerer, and you don't have some calipers, these bad boys, get some, because they're great. You go 0, wait, you push them together and you hit the 0 button and it's like, oh, I am now at 0, except I wiggled it. 0. And now you go, ooh, and you put the thing you want to measure in there and you close them and it tells you exactly what it is. So this is 2.64. So let's say 2.5. It's wood and it's a bit flexible, and you know, whatever. I'm going to decide that I want it 2.5. But, you know, you could know exactly what that was. So if you're trying to measure something to fit something else, you get that exact measurement. And then you add 0.3 for the clearance if you're attaching something to it. But it's good having the exact measurement. So 2.5 across the top. Oh, that's not the top. We still want this 40, I think. And we want this 2.5. Yes. Yes. Yes, yes, yes. Lovely. So that will be our first comb. And we can pattern it. Create pattern, and we are going to do half of the tooth spacing. Tooth spacing divided by 2. And this is going to be a spacing one, and we're going to have quantity of 1, and the direction is going to be along that origin. Oh, which we can't do. Let's do an extrude first. We will extrude our little dovetail to the right distance first. And I think 20 will be a good measure because our tooth spacing is nearly 40 and that just gives us a little wiggle room at the other end. So we're going to do 20 centimeters, 200 millimeters. There we go. Now we will have a point to reference our pattern on. And this, yeah, like this jumping backwards and forwards thing is why Fusion 360 is frickin' magic. And why it's good for people with ADHD, I think. You don't have to think of everything perfectly the first time round. It's quite forgiving. So yes, patterning, we're going to create a pattern, rectangular pattern. It's going to be of this box. It's going to be going in a that way direction. We'll just click on, oh, am I doing it wrong? I'm doing it. Yeah. Ooh, and we don't want these ones. We just want one of them, and we only want 1, and we want this to be tooth spacing divided by 2. Yeah, beautiful. And we're going to put one of these teeth on the top and one of them on the bottom. And the way we're going to do that is with the extrude function. And with the extrude function, we can, so before I was like typing in measurements because I knew exactly how wide this was. And we still know how wide it is. So we might actually do that. It's probably better. So what we would do is we will go, the distance should be tooth spacing divided by 2. Divided by 2. Except it's not. Why is it not? Oh, because the triangle business. Yeah, so we will do it. We will do it this other way. Yes, because triangles are different length vertically. Anyway. The sides are all equal, but it's not the hypotenuse. It's the height of the triangle. It's not the same as the sides, obviously. Otherwise it wouldn't work. So anyway, we're going to actually end up using 2 sides, but the extent type is going to be 2 objects. And this is the object we want to go to. So we don't have to even work that out. We can just boom to object. And then this one will be, I wonder if we can like enter in that distance somehow. Not sure that we can, but that's okay because I think that looks fine. And if we just have to change that one measurement in future, I'm sure there's a way to do it mathsy. I could do the calculations, but I think we're just gonna go with our gut. There's like a time payoff, you know, like you kind of got to decide what is worth your time. And I don't think that's worth my time. I think that'd be pretty easy to change later. So we're going to do the extent again. I just did it then by clicking on, oh no, it's still doing distance. We're going to do 2 objects and we're going to select that object. And then we're going to take it down 2 sides. So we're going to take it down to the 14 that we did before. 14, beautiful. Hello from New Zealand. Hello, Martin. Lovely to have a fellow Australasian, though that sounds very I don't like the Australasian term. It's too Australia focused. What are we? South Pacific? What's our ocean? Another fellow colony in the Southern Hemisphere? I don't know. Hello, fellow nerds. Please remember to show Billy some love and smash that like button. Thanks, Dan. I always forget to say these things. Smash that like button. Smash that subscribe button. Click that bell. All that business. Why is Fusion 360 so easy to use? I'm torturing myself with FreeCAD. I don't know. I cried a lot learning Fusion 360. There were a lot of tears. There was a lot of crying. This is me 4 years into my Fusion 360 journey. And I still learn new things all the time. Like, I started a job recently and I've been, you know, obviously other people do Fusion 360 stuff and I've been like looking at all their stuff and they use components way more than I do and they do stuff in quite different ways. And I'm like, is this because I learned organically and I don't, you know the real ways of doing things, maybe. So, you know, I think there's always something to learn. And definitely when I was starting Fusion, I cried a lot. There was a lot of tears because it was very frustrating. See you, Electronaut. Thanks for joining. Thanks for all your comments. It was very, very fun. Thank you. Yeah, so let's do our rake. We'll do the pattern again, and this pattern should be a little simpler than the last one. So we are going to do the features. Oh, it defaulted to features this time. No idea why, but yay. We are going to do both of those features. The direction will be along that axis, which is the same as our origin, but it'll be, yeah, along that comb. And we are going to do a spacing of tooth thingy. Where is it? Tooth thingy. Tooth spacing. Yes. And we only want one in the other direction. It doesn't really matter, but we only want one. And we're just gonna fill this up. We're gonna have an extra one there, but that's fine. We can delete that later. I probably should have offset them, but this little body, we will just remove it. And in Fusion, you don't want to delete it. So it has delete. You don't want to delete it because it will freak out later when it's trying to recalculate stuff. What you want to do is use remove, and that puts the remove function in down here so you can adjust it later. If you delete it, it kind of deletes it from the whole project and it gets all confused. So what you want to use is remove. But there we have it, our comb. Woo! And this looks like this one. Ah, and this one is nice and parametric. So if we want to change that tooth, like if we want to come back now, let's have a go. Oh, it won't work because I changed the what can we do? Can I make, I'm pretty sure I can make a dimension driven constraint. Can I turn one of these into a parameter? Can I turn this distance into a dimension? Yes. Okay, so what I might do actually, that is the half the height of the triangle. What I might try and do here, when I was being lazy, I didn't do this, but what we are going to do is try, can we reference that dimension? It's not showing us all the dimensions. I don't know that we can. Because it would be really nice to, because then we don't have to do any maths. And we can do the maths. We only have to work out the height of the triangle and then divide it by 2. But it would be nice not to. There's got to be a way to reference that dimension. I wonder if it can. That's helpful. Writes down remove. Yeah, Lee, really helpful. Delete, buggers everything up. Remove, totally fine. I whipped up a pretty complex project on a whim in Fusion without even knowing it. While I can do everything in FreeCAD, it's much more punishing. Oh, good to know, Sienna. Interesting. Smashed, says David T. I love it. I don't know whether this is the thing in other countries, but here in Australia, smashed means really, really drunk. Like if you were smashed, you were really, really drunk. So you're probably wondering if I'm a bit drunk. I feel like I've been a little bit all over the place. Doing things properly is cool, but us hobbyists can always afford to cheat a bit. I cannot learn FreeCAD to save my life, though. It's really frustrating. Aw. I'm off to work, but I'll catch the stream later. See you, Kathy. Have a good day at work. I won't be going too much longer. I think we'll do another half hour or so, and then I've got to get to work too. So, yes. I don't think we can. What I want is that line length. I don't know that you can. I think there was something about not being able to use driven constraints in not being able to use driven constraints in further calculations. I think there was some fundamental reason Fusion 360 couldn't do this. So I think what I'm hoping for is not super achievable. We might have to do the height of a triangle, which is, do we want to do it? Do we want to do the maths so we can make this fully parametric, or should we leave it here because I'm pretty sure this is correct? I'm pretty sure this is correct. Let's not waste time. Let's not. I won't bore you with making parametric stuff. But there's our comb. That's good. That's what we want. What else should we do? So I did need a wider spaced comb, and maybe I should put it on the other side of the original one. This one? On the other side of this one? Maybe? And I only need it to be on the one side. So let's do that. Let's put another comb here. Yeah, because it's not too wide. It should fit on most printers. It's only 5.5 centimeters. So let's put another comb here. And then we don't need two tools. We can just print the one thing. Sound like a plan? I think it sounds like a plan. We will do that. Alrighty ho. Now we can reference this in a new sketch. So let's create a new sketch. Oh, not here. We will, oh yeah, here's all right. Yes, here is a good spot for it. I was just thinking here in the timeline, because we'll move it around later and we can remove those moves. So we're looking at the bottom now. Let's look at it from the top. Wunderbar. And we started the comb from here on last time. But let's start it from here, because if you're flipping it over, I mean, it doesn't really matter, it's two-sided, but whatever. We're gonna start from here. And remember I mentioned that project and include and intersect, really handy. So let's use that this time, and let's use the intersect. And we could use project as well, but let's use intersect for the sake of show and tell. So I'm gonna select this body down here and go, okay. And now if I make all my bodies invisible and look at it from the top, we will have an outline of our comb. Oh, and if we change anything, the outline will stay the same. The outline will update to be whatever we changed it to. So it will always be accurate, which is nice. So we can reference things on it. So if I change the length to 20 or 27, we'd always still be able to reference these points. So very handy. Yes. Nate, Kerry, found your channel through Zach Friedman's interview video, showed it to my girlfriend, and now she wants a resin printer to make sparkly things. Right? Oh, it's my favorite thing about resin printers. You can make everything sparkly and you can make it any color you like. I love that about resin printing. It's the coolest. It's the coolest. Real Thunder's link branch is a massive improvement. Oh, is this in Fusion, Siana? Is this in Fusion, or is this in, what's he who? FreeCAD. I found about Zach Friedman through Billy Rubin. There you go. Yeah, Zach is amazing. I've known Zach for a year and a bit, maybe. But like, oh, what a brain. What a brain he has. Just so clever. I'm so glad he started a YouTube, because he's always made amazing things, just amazing things. And I'm so glad he's now sharing them with the world. It's just super. Like when I first heard about the Power Glove, where you can like write in midair and you have like a computer on your face and all that stuff, like, oh, so cool. I think I met him through Cyberdex. Was it Cyberdex? I'm pretty sure we met through Cyberdex. Yes. Anyway, we only need one comb on this one. This one's very simple comparatively, but we will look up the proper dimensions for this. The proper dimensions are spaced at 2 inches. So let's use 5 centimeters because, inches. That's the only reason. Inches. So let's put another pattern in here. Oh, we need to extrude it first. We need a bit of tooth. So let's turn our bodies back on. Bodies, and we need one of these, and we're going to extrude it 2.5, so it is the same as the teeth on the other one, the thicker teeth. We're going to use thicker teeth, like the same on the other rake. Because yeah, this is where you do the big pulled patterns. So that one that is one of my favorite, this one, where you do the big sweep through here, that kind of sweepy pattern, that is done with a bigger rake. And you kind of want it to be a bit thicker because you want it to kind of grab a bit more of the paint and pull a bit more than the finer rake. The thickness of the teeth is sort of important. Oh, look at this. This is interesting. Oh, it's a little bit higher. Maybe I should be putting it on this side. Yes, I should be putting it on this side. That's okay. We can just extrude it up because we know the top and the bottom is the same. This is probably not the best way to do it, but it'll work for this instance. So we're going to do two sides, and we're going to go, the first one is going to be 2 object up here, and then the second one is going to be a distance, and it's 7. 2 object was 7, wasn't it? I'm pretty sure it was 7. Say 7? Pretty sure when we went distance. Yeah, 7. So 2 object, that's 7. That should be, sorry, 2 object, that one. And then this one will be 7 minus 2.5. Ah, negative 7 plus 2.5. Negative 7 plus 2.5. Yes, that's in the right spot. Oh, golly gee. Okay, there we go. And we'll do a pattern to make this one. Pattern. We want a feature, which it defaulted to this time. I'm not sure why I was doing faces before. Maybe it's like, oh, you like features? We're going to do features now. I don't know. Anyway, we're going to do a feature. And we're going to go, the directions are along this line, and they're going to be spaced by 5 centimeters, so 50 millimeters. And we're just going to fill it up. I think that will be 5 things. Because, oh, it's not quite 5. Oh, no, that's good, because you actually want a bit of space. Because you need the room to maneuver. So we're going to just leave it as 5 repeats, and we'll leave the end free. Cool. So we just have the 4, 5. I can't count. 5. Okay. So, and now when we move it, they'll kind of intersect each other, but we can change this last move over to here. So now we have 2 pieces. And was this first move also a... What did that one do? We could probably delete that move. And, oh no, that was the rotation. Oh yeah, okay, I understand why it's 3. That's fine. Yeah, okay, cool. So that's our comb. There you go. And this is it assembled. Boom. And it spread apart. Boom. And they all should have a nice flat surface on the base, and they do, and we can tell because there's no lines in between the head of the comb and the teeth. So this should all print pretty well. I'd want good bed adhesion because these are tiny little parts, but I think we'll do okay. I think we'll do okay. I think this will be really interesting to try on the belt printer. I'm going to give it a go and see what happens. And it would also be good because I do eventually want a larger tray for making paper because I really want A3. This is A4, which is like letter size if you're in America, but we have a really neat style of paper that every time you move like to a larger sheet, you like join 2 sheets together. So A3 is double this size. And I really want to be able to do double this size because I think it's better. I can then get 2 end papers for an A5 notebook out of them, which is the size I really like. I like half-size notebooks, so half this sort of sheet of paper. That's generally what I use for every day. So yeah, I really want an A3 size sheet. So this will be really good. I'll be able to make a larger one in future. So yeah, there we go. 2 different combs. I don't know what else. I was thinking of making another watercolor palette, which I have these cute little, I'm so obsessed with them. I don't know whether everyone else is bored of them. I'm not bored of them, but maybe other people are bored of them. Actually, I'll show it. I've got a better one. 2 secs. I'll go grab it. Talk amongst yourselves. Still not easy or self-explanatory or sensible, but less broken. So the thing with FreeCAD is, obviously totally developed open source and by people who are just doing it voluntarily. There is an update coming. So one of the developers, the main developers of FreeCAD is also one of the main developers of Debian, like Linux. And he has made a branch of FreeCAD that is really, really awesome, performs really well, more intuitive. and much less buggy, like weird topology stuff doesn't happen anymore and stuff. He didn't get it done quite in time for the last review cycle for the last release of FreeCAD, but the next release of FreeCAD, they've now had a look at it all and checked that it's all hunky-dory, and it is. And so the next release of FreeCAD will be freaking incredible, and way like a huge step up in user interface and usability and all of that sort of stuff. So definitely keep your eye on FreeCAD for the very, very near future. You can also download his one already, his branch. It's like on his GitHub. I can't remember his name, but Brody Fairhall will know. If Brody hasn't done a video, I think he has done a video. Brody Fairhall has done a video on it. So definitely check that out if you are into the FreeCAD situation, because yeah, that will definitely help FreeCAD wise. If you add files where each of the tooth connects to the tomb, if you add fillets where each tooth connects to the comb body, you'll reduce the risk of them breaking off, reducing the stress concentration. That is very true, Eric. Let's do that. It's a comb for bookmaking, Wonder Maker. It is a comb for making marbled papers. So water marbling is kind of like hydro dipping. It's like the original hydro dipping. You get water, thickened water, and you put paint all over it, and you comb it with combs, and you rake it with rakes, and you make pretty patterns that you put in the front of books, like in the front pages. Though this one actually isn't a marble, but you get the idea. You use them for bookmaking. So it's kind of bookmaking, but it's sort of paper making, and it's a decorative art. That's what we're doing. Yeah, Eric, I love the fillet idea. Let's actually do that. I don't think I want to print these now without the fillets, so let's do that. So we will roll this timeline back to when we have first got a tooth on each of these. Yes, we'll do it here. Real thunder. Ah, cool, gotcha. Oh, I can't put a fillet there because I put it right on the edge. We could cheat. Shall we cheat? Let's cheat just a little and just make it 1 mil this way. We'll cheat. If I thought about the thing before, I didn't think about it. If Eric knew my intentions and somehow predicted that I was making this in this way, then we could have done this earlier, but we're not there. So we will do this, and we will go -1, and we'll just put a tiny little bit right there. Turn off this sketch, and now we can fill it both sides. I think a millimeter will be fine. Maybe we should make it -2. -2. Yes, let's do that. All right. I like this fillet business. Fillet. Let's put a fillet here and here and here. Yes. And also here and here and here. Not there. There. And we're not going to do this one because it's not an angle, and also because we want that flat on the bed. So this is genius. Eric is so clever. Anyone who hasn't met Eric before, this is Eric. He is a brilliant human. Very, very clever human. Let's do the whole 2 millimeters. Yeah, why not? Okay. And now we might have to do the pattern with the... We might have to redo the whole pattern. I don't think we'll be able to come back and select this fillet as well. Nah, it's not going to be. Maybe if I just turn the direction off. Sometimes if you just... Yes. And then the direction. Oh, yeah. Okay, we cheated it. Oh, too many pattern instances. Okay. Okay, I'm sorry. We probably should do that double pattern thing. Like do half and then half again. Yes. That'll be way better, Eric. Thank you. Very, very appreciated. That'll be lovely. Beautiful. Look at it from above now. It probably looks all Art Deco. Oh, it looks so Art Deco. I love it. I love it. Okay, and let's do the same for the other side of the comb. There, yes. This comb's gonna get just a little bit too big. I might have to come and rethink this later. Or we could just change the sketch. Let's just change this sketch. We will stop this being coincident here. I never get the right coincident point. Yeah, that wasn't the right one. It'll be... It's always the last one, isn't it? Okay. And we'll just put those ones back together because I don't know what they were. And we'll just chuff this over by, what did we say this was? 2.5. So let's do 2.5. Yeah, okay. Beautiful, beautiful. Go back and just add more faces to the selection. Yeah, so I tried, but it doesn't like it every time. Most of the time, in fact, I can't actually add more faces if I have a direction already chosen. I don't know why that is. It just never seems to work for me. So I always have to like turn off the direction, add the faces, turn on the direction again. I don't know why. But it just always does it to me. Anyway, we're gonna fill out these ones. We're gonna fill out them. I think I did 2.5. 2.5. Yeah. And now we'll do it again. So I'll try again. So pattern. So if I want to add another object, another feature, and it won't let me. I hold down shift and it won't let me, and I hold down, it just won't let me. It just won't let me. Yeah. So all I have to do is go turn off the direction. Turn off the direction. Ah, no, features. Oh gosh, let's just start again. Turn off the direction. Select the other object now that I can do that, and then turn on the direction again, and it will work. I don't know why, but Fusion 360 has always done that to me. But there we go. Look, more strengths. I love it. Thank you, Eric. Genius. Very good. Jolly good. Jolly good indeed. Cool. So that's that comb, and now I want to do this one too, I think. But I might do that later. Oh no, I don't know. Anyone want to see me do a watercolor palette? I don't know. Did I save the watercolor? I don't think I saved the picture. Meh, can't do the watercolor palette. I'll show it to you though. I made this cute little, I 3D printed actually, this opal. You can't really see it. I wonder if we can get better light on it. Nah, but this actually is flaky, and it has like an opal-like shine, and I 3D printed the opal for the front of this little pendant. I didn't 3D print the pendant. Huh, that would be cool. But yeah, I was gonna put a little watercolor palette inside here, which I have been doing with everything lately. I'm obsessed with tiny little watercolor palettes. But maybe let's not start that. Let's not start that. I don't know. Maybe I should just round it up. Should we say goodbye? Should we say goodbye? Yeah, let's. Thank you so much for joining me today. This was really, really lovely. I really, really enjoyed it. It's so much more fun hanging out with people while I do this sort of stuff. And I really haven't done any Fusion for a really long time, actually. I've kind of been feeling a bit meh about making for a while. So having people around, lovely people such as yourself, really, really helps. So thank you so much. And yeah, thank you to all my amazing patrons. I will jump back and give them a shout out. Thank you to all my patrons, and particularly people on the list of legends. You like make all this happen, and I'm really, really grateful for it. Yeah, I wouldn't be able to do this sort of stuff without your support. So thank you so much. And yeah, next week I think we're jumping back to the Chimera, and I will hopefully update the firmware and stuff before then and make sure it's all plugged in and working, and then we will finish mounting it and start a print on the Chimera. So that'll be exciting. Keep tuned for that. I'll put some word out shortly, and then after that I think I will have these water marbling combs done, and then we can do some water marbling on the stream, and I can show you how that all works, because it is really, really cathartic and quite easy to get into, and just so much fun. Like, it is so nice to be able to unwind with a bit of marbling. So we'll do a very zen one, I think, the following week. Yeah, thank you so much for joining. And yeah, if you have any suggestions or anything else, please give me feedback. It really, really helps me. I have a link to the Discord in the description if you don't want to catch me here on YouTube. And I also hang out on Twitter quite a lot. So yeah. Thank you everyone for joining, and have a beautiful evening or day, and I will see you on the internet. Oh, when are you doing another Fusion class? Oh, like with a paid one, like with Make? I'm not sure. It's a little bit hard with my new work schedule. I'm working more than full time. So I'm doing like 6 days a week most weeks, and it's a little bit hard for me to schedule at the moment. I'm also not technically there permanently yet. So I'm hoping to apply for the permanent role very, very soon. And yeah, so I'm not really sure on a lot of that front. But I will schedule one in as soon as I can. I was kind of thinking over the Easter break, but that's only in a couple of weeks, and I just didn't act on it soon enough. And people are probably going away, and maybe not going away, actually, now that I think about it. Lots of the world can't go away. I'm very lucky here. Yeah, I probably should have acted on it a bit sooner, but I'll try and get one in the not too distant future. In the meantime, all the slides for that Fusion stuff is on my website, which also link in the description. On the blog page, there's all the slides that I went through. I might also try and just do a sort of fake recording of that class. Obviously, it's better to have me in the room because you can ask me questions and stuff. But I kind of, yeah, I want to get the knowledge out there. And I think I must have hit on something pretty good because the feedback I got was really, really good. I was really worried about it because I really struggled to pick up Fusion. So I was really, really happy to see that so many people just loved it. Like, the feedback is crazy. So yeah, I'll have to get one out soon. I'll have a good think on that. Sorry, it's not a very good answer, but yeah, hopefully see you soon. Marbling with music. I love it. Do you like weird electro synthwave music? Because it's gonna be launish. No. Yeah, thank you to everyone who shared tips. I legit learned so much tonight, so thank you all very much. It kind of pays to be yeah, doing this in front of people, I think. I hope they keep me too, Sienna. I hope they keep me too. I really hope. But yeah, we'll say goodbye. Bye everyone. Have a lovely evening and day.